Well, it's 12 o'clock. Maybe we should kick off. Happy are those that are punctual, if you can stand the loneliness, as they say. Well, good afternoon to our panelists, and a good afternoon to all our participants out there, our SAFMA membership, and welcome to this, what has become a regular webinar in terms of SAFMA activities. And thank you for joining us, and we look forward to an exciting and informative program. We have a wonderful lineup on the panel today, and I think I'm going to introduce all three our members right up front. First up today is going to be James Shirley, who's the head of smart buildings at the Motseng Property Group, a diversified and multidisciplinary player in the built environment in South Africa. James grew up in South Africa and then moved to the USA and ended up studying chemical engineering at the Colorado School of Mines, and then did some sales and marketing stuff, and then came back to South Africa in 2003. He worked for Kayamana Energy, and in 2013 joined Schneider Electrical to head up the solar business in Southern Africa. He's a certified measurement and verification professional and was admitted to the Association of Energy Engineers in 2012. He has also served as chairman of the Sustainable Energy Society of Southern Africa, and he's been on the board of the Renewable Energy Council. He currently is, as I said, the head of smart buildings at Motseng Property Group, and has been there since earlier this year. He will be followed by Martin Lumbrecht, the National Facilities Manager for the Liberty portfolio within the Accelerate JHI Group. Martin has recently joined Accelerate and has many years of consulting and facilities management and business transformation experience in South Africa, West Africa, Central Africa, and the Middle East. He spent a number of years at Old Mutual Properties and followed that with time in Nigeria and Iran working for MTN. Martin has a degree in mechanical engineering from the University of Stellenbosch and an MBA from the University of Pretoria. Our third speaker today is Klopper, who is very well known within SAFMA circles, having served on the board of directors of SAFMA, having been a past chairman of the board, and has been around the block for many years in facilities management in South Africa. He holds a master's degree, one of the few to hold a master's degree in facilities management in this country, and he's currently the national facilities manager with the Redefined Property Group, where he looks after some 350 or so buildings. So it's just a tiny portfolio there. So without any further ado, I'm going to hand you over to James, who's going to give us an introduction and an overview as to what smart buildings are all about and how to go about looking after them and putting them in place. James, over to you.
Thanks, Cliff. I really appreciate it. What a great introduction to the fellow panelists as well. Hi, everyone. And of course, to everybody watching today. I hope it's going to be valuable for you. Can everyone hear okay on that side? Perfect. Okay, so what I'd like to do is really start with by just bringing a little bit of context to what's happening in facilities and in buildings these days. I always like to think about a mobile phone. You know, 15 years ago, we got a mobile phone, or you know, everyone had a sort of a basic Nokia, and that's what we got. Today, though, every couple of years, we upgrade our phones. We change the technology that's running in. We've moved away from these analog devices into really smart, efficient, digital and app-based analytic devices that we carry with us. So the same thing is now starting to happen in buildings. We're starting to see convergent technology occurring. So what we're seeing is that the convergence of communications between equipment, various different equipment, and of course, between the different manufacturers. And there's a few main reasons for that. The first one is that technology is changing very, very rapidly. So it's not really within the scope of a single OEM anymore to manufacture every different device which a smart facility requires. I'm sure you'll see in Martin's discussion in a little bit, he's going to go into a lot more detail on these things. But one of the great things which I think he'll talk about is having a BMS doesn't give you a smart building. I think he'll discuss that in a lot more detail. Rather, it's a lot more being added to it today. So clients want to be able to see their building as well through a single pane of glass view. They no longer want to see multiple systems running in a building where specialist training is required for each different type of system. Also, as the buildings become smarter and they start doing a lot of learning for themselves, what one piece of equipment senses might actually affect how several different systems respond using that same piece of hardware. A great example of this might be let's say a diffuser in a building. That diffuser might have a motion sensor built into it to determine whether it should be heating or cooling, whether there's somebody in the room or not. But at the same time, that can start switching lights. It can start looking at lux levels. It can start gathering a lot of information and feeding that back to a multitude of different systems. And then, of course, from the convergent technology approach, the information gathered on a single building needs to be shared by multiple stakeholders for a multitude of reasons. A great example of this is, let's say, energy management or power monitoring. Proprietary systems might be very difficult, or it might be difficult for the facilities owner to share the energy data with other companies that want to put in different solutions for them if they don't have access to that data very easily, very quickly, and very cheaply. So a quick summary then of the convergent approach that we're looking at is smart buildings are made up of interoperable systems. They're all capable of speaking the same language, which we refer to now as an open protocol. And there's a variety of open protocols. Some devices do it directly using protocols, for example, BATnet or Modbus or MBus. Other systems might do so by sharing information from one database to another database, either directly or via the cloud using web services, as an example. So there are a lot of different ways of sharing the data, but it's important to understand that it can happen either at product level or at system or cloud level. What's important then that we feel is when deciding on a way forward is really to select open systems which communicate on common protocols, but also at the same time, we have to pay a lot of attention to cybersecurity standards and measures, because it's absolutely critical that we don't expose our buildings by allowing them to communicate easily. A great example of this was a client in Dubai. He hacked the lighting system in a hotel, and at 2 o'clock in the morning started turning on everybody's lights and music and everything in the room, because that system wasn't particularly secure. So as a hotel operator, you don't want that exposure. The second key point that I really want to discuss today is that buildings are going to be adaptable and reconfigurable. Now more than ever, especially with the COVID crisis, we have no idea what the utilization of a building or a fleet of buildings in the future is going to look like. All we can say right now is that they're going to need to be far more digital. So from the digital side, really IP-based systems. It's going to allow for working from home. It's going to allow for app-based individual control and automation, whether for comfort or for tenant experience. And we need more augmented support for remote facility management. Andre, I mean, if you're looking at 350 odd sites, for you to be able to check into any of those sites from your home is going to become really critical. And it's the digitization of the building that's going to allow that to happen. On top of that, the buildings are actually going to need to be reconfigurable. So what I mean by that is we're no longer building a 6-story building for one client. That same client may have had 6 stories, but in the future may only require 3 of those floors. And now what's going to happen to the other 3? Well, we need to be able to reconfigure that quickly, easily, and at low cost. And that's from things like access control through to workplace layout, through to security. How do we manage security access as things change quickly and easily? Of course, what about billing? You know, we might want to bill each floor individually. And the telephony, how do we change our telephony system without having to strip the whole thing out and put a new one in? And then finally, the buildings also need to be adaptable. So the adaptability part brings in ideas like constant commissioning, that we don't know whether a building is going to be 100% occupied, 60% occupied, 50% occupied, or a mix of those throughout the day, and that we need our hardware to be adjusting to the occupancy, you know, as quickly and as efficiently as possible. We also need to look at occupancy-based energy consumption. And we need to look at other measures for demand management. How do we manage water? Do we need to circulate, let's say, hot water through the building all the day? Or do we need to say, well, based on our occupancy, we only need to circulate it at certain areas? Okay. So again, similar words, but very different applications between reconfigurable and adaptable. So to summarize that, buildings currently have got an electrical, a plumbing, and an HVAC skeleton throughout the building. Moving forward into a smart building, we need to have a digital overlay on top of all of these, a nervous system that sits really on top of all of these. Without that, if you're a portfolio manager, your building is going to struggle to compete with other offers in terms of comfort and guest or user or tenant experience, in terms of energy efficiency, now energy being all the wages, not just electricity, in terms of operational efficiency, again, your staff, your subcontractors, how do you manage their access, their time very well, in terms of safety within the building, and of course, in terms of security and the ability to meet the changing needs of every client. So I haven't wanted to take up a lot of time because I know Martin's got some really, really good information for you. But just at a really high level, I think the convergent technology approach is critical to understand. And the fact that building fleets are going to need to be adaptable and reconfigurable in the future. I think from a question perspective, we'll probably take them at any time as they're written, and then we'll answer them all as a group at the end. But if I can hand over to Martin, please, over to you, and off you go.
Thank you, James. You know, my brief was from Cliff was to talk to you guys about design considerations from a smart building perspective. So I'll try and focus on that and try and slot in and build on what James have basically alluded to already. So this is purely from that perspective. So I don't profess to be a specialist in smart buildings by all means. I know enough to be dangerous. But I'll try my best to just impart a little bit that I do know about it from a consulting engineering perspective or designer perspective. So as a designer, or as a person dealing with designers, there's a lot of questions that you might be asked. Simply, what is a smart building? What technologies enables it? How do you ensure interoperability, like James said, between all of these, the data exchange of all these different systems in a building? What data and IT security is required? How do you get the data into the cloud? Which vendor do you select? Because there's many of them out of there. What does the building look like in the future? And what the hell do you do with all this information that you generate as a result of putting these systems in? So from a definition of a smart building, I'll purely basically quote from the Building Efficiency Initiative that states that the building that delivers useful services that makes occupants productive at the lowest cost and environmental impact over the building's life cycle is defined by them as a smart building. Suffice to say, guys, that it means a lot of things to different people, depending on who you are and what you want to do with this. But it does require adding intelligence into the design of buildings right from the beginning of a building in today's life. So it does use converged networks, like James alluded to, that connects a variety of subsystems. We're all used to the traditional BMS that sits on its own, or maybe a lighting control system that sits on its own. So all of these sub-agents are basically being meshed into converged networks, so you can actually extract all of the data to a single point, so to speak. These stuff uses IoT sensors and building automation to not only look at look at the data, but also to control. You know, it's not just measurement or observation of what's happening in the building, but it's also to control it. And if a building is fitted with a BMS, or, you know, it's not to say it is a smart building. You know, if a building is just collecting data and not doing anything with it, it's also not considered a smart building. These things in future will continuously learn and adapt, if I can say that. As an example, there's an edge building in the Netherlands. I mean, this building understands where you live. It knows what car you drive. It will put you in a parking spot which is most convenient for you in terms of how close do you work to a specific area, for instance, or the size of the vehicle. It knows your schedule for the day. It knows what kind of workstation you require, whether you're going to work in a work group, or whether you need a concentration booth, or whether you're going to be an open plan. And by the time you get there, it's also going to know what kind of lighting level and kind of temperatures you prefer. You know, this is the kind of stuff that guys are already doing in buildings. Suffice to say that there's no one recipe around design, you know, or around what you should be doing, and nor do I think there should be. As a matter of fact, what's actually required in the future is there's people that are change agents in the space that can really challenge the old ideas in terms of what you have around these things, and start innovating in that space as well. As an example, you know, you've got architects or building designers are thinking about even like a facade. You know, most of us are dealing with buildings and we just look at the facade as an envelope, but the facades in the future could serve multiple purposes in a building. It could start generating power. It could start growing food. It could it could start being carbon absorption structures in green cities, for instance. So building facades could develop, you know, as a very fixed element, also to become part of a smart system. Then just some considerations that I think we need, as a designer, that you have to take cognizance of. A lot of owners and operators and occupants expect a hell of a lot more from the built environment going forward. I think, you know, as COVID has basically proven, you know, suddenly, you know, a disruption like this could challenge, or very easily challenge, what we do in buildings and how we consume buildings, if I can say that. And they should rightfully expect a lot more from these kind of static structures that we mostly have. James talked about adaptability and all of these things, so that will be definitely the trend in the future. And I think yesterday we discussed that a lot of presentations that was done around this space 5 months ago is irrelevant already. You know, so we all were forced to, through this, let's call it social experiment, actually, to a degree, of what the response to COVID-19. That's what I'm referring to as a social experiment that actually forces us to relook at and question ourselves in terms of how we design spaces and how do we consume it. So the technology, like James says, that it changes so fast. You know, you have to really, you have to really be in that space continuously to keep up with it. Otherwise, it just moves too fast. And there's a hell of a lot of tools and systems and applications around, and that drives confusion to a lot of normal people. If I, excuse the use of normal, but just the normal man in the street or building owner. A lot of buzzwords are used, IoT, big data, smart, open, and whatever. So what does all of these things mean? You know, it does leave some uncertainty. So as a designer, your job is to actually provide clarity and remove uncertainty. So getting to the important bits, the big thing from a design element is in selecting technology. There's a few things that are important, and I think probably the first one to start off would be to ask yourself what problem are you trying to solve here. And in saying that, as we all understand the inefficiencies in different businesses, or you might not, but your job is to really try to understand what inefficiencies there are, and with what kind of technology that you select, you can actually try to get rid of those inefficiencies. So you have to apply your mind with the client with regards to how do you want to benefit the business through the application of these technologies. It's not so much choosing the sensors as really understanding what do you want to do with it to solve a particular problem. I think the focus is just from a problem-solving perspective rather than a technology-focused perspective. So as a good example, like I say, if you look at a lighting solution, there's a lot of systems out there that purely controls lighting, switches it on and off to reduce energy consumption, and that's about it. Or even maybe even these days monitor it and switch it on and off as your facade lights up or you get more sun and so forth. So to change the lighting levels dynamically. But if you select if that's not the only problem you want to solve, then you better understand it. You could be solving a problem like a diagnostic information from the monitoring system. Also, that's got detection capability, so that you can actually solve a maintenance problem as well. So you've got to ask yourself, what problem do you want to solve in the first place? The second thing to consider is, from a system perspective, is what is your setup strategy? And you have to have a robust plan in terms of doing this. Just falling into this is not the right answer. I think you've got to be deliberate, and you've got to select a robust solution. It's got to be conversed, IP-based, open, all of these wonderful things like James said. Because if you start from the wrong starting point, you're not going to end up where you need to end up, or you're going to get there, but in a very expensive way in the long term. So the simplest way that I can advise on is to really POC this thing, or proof of concept it. If you understand the bigger picture, maybe you've got a very specific problem that you want to solve that problem. Get a few sensors in, start doing what you're doing, collecting the data, let it tell you that you are solving the problem, and then you build a system from there without having, on a future-proof platform, rather than just, having to chuck stuff out and put new stuff in. And the third consideration here is how robust are the data capabilities of these solutions. So if you've chosen a robust solution, you have to make sure that it doesn't only just monitor, but also that the data capabilities in the system can handle stuff like outages, can handle spikes, can handle missing data, so that your analytics in future doesn't become a problem. So you've got to make sure, again, what solution you put in place is robust enough. So that's not only just monitoring, but also control that you want. Lighting control systems are typically, cost about 20% of a lighting budget, as a rule of thumb. So installing controls, you should be able to save around 30%, right off the bat, in addition to maybe doing an LED conversion. So the important thing to consider here, and the last thing, is the return on investment. So after you've done a robust solution that's got the flexibility and everything, is to look at the return on investment. And here, I'm probably just going to throw one or two slides up, just to maybe, give a bit more clarity. I want to talk about the 300 rule. We all understand, as consulting engineers, or as, in developing business cases, that we can quantify stuff like energy savings and efficiencies and so forth. But the stuff that we can't really quantify comes to play with regards to productivity, leakages in buildings and so forth. So I'll briefly just share that with you, if I may. I just want to. Can you guys all see that? So if you look at this slide, the long and the short of it, we all understand, if something costs you 3x in terms of your energy and water costs in the building on the left, in the middle here is basically the lease cost will be about 30x, 30 times the size of, or 3 times the size of that previous one. And then your employee costs will be 3 times that size, a factor of 10 again on top of that. So if it's costing you 3, your lease cost will cost you about 30, and your people cost will be about 300 times the factor of your energy. And this is where we basically see a big opportunity with regards to calculating return on investments. The problem is a lot of people don't really understand how to do it, or a lot of traditional designers or technical people don't necessarily know how to go about this. So you either need to work very closely with your client, or you have to partner up with somebody that knows how to do it. So from a designer role, I think I just want to, I'll just put a bit of a model up there. It has to start with visioning with the client in terms of what you want to do. You need to understand why you want to do it, and you need to understand how this is different. You need to build a business case, and using this 300 rule, so to speak, to be able to quantify something, because if you do, you'll get a hell of a lot quicker return on investments than purely focusing on the traditional energy savings component, for instance. And this is where it can be powerful. Obviously, yeah, it's relevant to what kind of investor is in a building, or if it's an owner occupant, they will have a hell of a lot more interest doing that versus a pure raw developer that just wants to get it cheaply out there. And whoever else occupies that will be sitting with that problem. And the third element is actually the system selection and design, in terms of how to go about that, so that you ensure that you design a robust solution for your client. I'm not going to focus on construction and operations. I think Andre can talk briefly about that. So if you talk about the developing a vision, I spoke about that. The smart design, the big things to focus on there is the ability of the systems to share data, the converged network element, the tight integration of IT departments. The availability and accessibility of data is critical, and where you store that data is also critical. It's very important to consider this infrastructure questions, because you can't go to system selection, the next step, if you haven't sorted out these fundamental infrastructure things. The importance of the converged network, it provides you with that centralized management of IT resources that really will help you to improve flexibility. It will reduce your hardware requirements, as well as make your solution scalable in future. Like Andre's got 350 buildings to look at. How do you do that? And as I said, the problem with what you will do with all of that data, once you've got it available, is selecting the system that gives you the capabilities of just throwing the data in and using a BI tool. You want to compare maybe foot traffic with temperature and the impact of that. You want to be able to take it very simply, put it together, and do it without having a PhD in data analytics, behind your name. You want to be able to make it as simple as possible. And some solutions are superior to others, and it doesn't cost you a lot of money. As an owner, you can run those analytics on top of it. Then the last point I just want to make is on system selection. I'm not going to talk about cost and flexibility. That's straightforward. Control and convenience. If people are sitting in a building, they want control and convenience. If they don't have that, adoption of these things are low. Typically, you get a lot of applications on mobile applications that gives you those kind of things. There's millions of them on app stores. Not all of them meet the rigorous security requirements from IT companies. It's important that it meets it. And secondly, it's important that it's very simple and intuitive, and it gives meaningful feedback to occupants. I want to maybe use the app and see what's the temperature in a specific location of building, and choose to rather work at 24 degrees than 22 degrees. That will kind of save you this old age HVAC problems that we have in buildings. Security, without question, is absolutely vital, and ensuring that as part of your system selection, that the protocols that you are using are open. This is just a quick picture, what James discussed. You have to look at a converged network. Cloud-based solutions are critical, and there's a hell of a lot of multiple access systems that sits on the edge, that are different edge systems that you've got to bring together. And for the sake of time, all these multi-agent systems, I've just categorized them here for you, and we'll share this back with you so that you can read it at your own time. It could end up being a hell of a lot of stuff that's got to be brought together into a single aggregate solution. And without further ado, my last point as a designer is you have to consider the codes and standards that you want to use. You don't want to pigeonhole anybody into a solution that in future will be very expensive for them to run, and not make it possible for different service providers to work on there and help you at low cost to keep these things up. And there's a bunch of links around this. So yeah, it's a short and sweet one. So hopefully that gave you a bit of more clarity in terms of design considerations itself. So over to Andrea. I think you can talk about how you use these things in the building, not only after this design.
Thank you, Martin. After the previous two guys, there's not much left to say. I also think the little bit I need to talk about is, a little bit about the airy-fairy stuff. So I don't have to be that factually. I think from the three of us, you've heard that there's, or between Martin and James, that there's different definitions to what is a smart building. And I think all buildings are smart. Some are smarter than others. And then you have buildings that are, for a lack of a better description, Einstein smart. Because all buildings have some level of control, whether it is the aircon, whether it's building management, lights, as Martin mentioned, or a combination of these. So I think all buildings are smart, and you just have smarter building. Some buildings are more smarter than others. Futurists are predicting that by 2025 there will be 1 trillion building sensors in place around the world. And that is about 120 building sensors in operation for every person alive. I think that gives you sort of a sense of how big and how wide and how integrated the systems seems to become, and how it will monitor environments where we work, as Martin explained about the building in the Netherlands. And Martin, I think if I may make a suggestion, if you could put a link to that building perhaps in your presentation, it would be a great thing, because it's really a good read and understanding what that building really does. I think it just stops short of making your favorite cappuccino on your birthday when you enter the building. Smart buildings is the way of the future. It is the way of the future for facilities managers. Building management is undergoing a major transformation as more IP-enabled equipment is installed and started to being used. And it opens a whole new arena for facilities management with a whole new raft of capabilities, from data collection and analysis to integration with in-house systems and consolidated administration. In short, it should make a facilities manager's life easier. But with that comes a lot of integration with systems, information, the ability to interpret that information, analyze that information, which will give you a deeper insight and a faster situational judgment and reduced administrative workload. And I hammer on the administrative workload because as facilities managers, we just, by the very nature of what we do, work in a very regulated environment. Now, whether it is health and safety, machinery, building, construction, and a whole host of other regulations, we are working in a very regulated environment, and it is becoming more regulated, and much higher levels of compliance are required. And smart buildings will go a long way in helping and assisting with this process and managing it going forward. And without going into all the detail, I'm going to touch on, I think, 3 things that are critical for any smart building or critical any smart thing out there. And I think the first thing is big data. Currently, through various systems, and may it be integrated or as individual systems, we gather a large amount of information, from access control, when people come into the building, what are the peak times, to information that is collected through lift systems that are out there, Kony 24/7 being one of them, to see the usage of lifts and to which floors at which times, to air conditioning, to light switching on and off, all those type of things. So a lot of data is collected, but that data is not necessarily integrated and analyzed to get a holistic picture of exactly what is happening in a building and how that information can be used and applied to further enhance the benefits from reducing, for instance, the energy usage when the building is less occupied and those type of things. So gathering of big data is a big thing, and the integration of that data and the analytics behind that data is critical. Another thing that stands out for me from a smart building perspective is machine learning. Because all these sensors essentially are monitoring machines. Machines, as Martin quite rightly said, that we want to be able not just receive information from, but be able to control and manipulate to either switch on or off, or do different functions and tasks at different times. But also to be able to have these machines learn how buildings operate and how people within those buildings function, so that these machines over time could learn how to adjust, how to make small adjustments as the day progresses and the sun moves, blinds open and close because it follows the track of the sun and the sky. And ultimately that would lead to something which in facilities management, dare I say, is the holy grail, is predictive maintenance through machine learning. Predictive maintenance where because the machine has learned from not just its own environment, but from big data sets outside of its environment, that if a lift starts, opening too quickly or too slowly, that there's potentially a problem with a particular part, and that notifies the lift company to come out. And as the technician arrives on site, it almost already have done the troubleshooting and said, well, from learning from other instances of the same type of incident, we can now say that this particular part, door sensor for argument's sake, is the first thing you need to look at, and you need to look at that specifically. And if that is not the issue, then the second most likely issue is the next thing. And so it could speed up the fault finding process and actually give that technical person on site a quick insight and guidance onto what to look for in that particular piece of equipment, and get it up and running, and thus reduce downtime. Predictive maintenance, I think, is a big game changer as well when it comes specifically to reduction of cost, because you'd actually address things before they break. And that is being just more than proactive management. Proactive management is, yes, we service generators 4 times a year. Yes, we service that so many times a year. Where with predictive maintenance, you could actually prolong those services potentially and only fix on when it is necessary. And a good example would be generators currently. As a preventative measure, we service generators on a regular basis 4 times a year. But if you look at the runtime, those and depending on where you are and load shedding, you could actually go to a situation where you service generators based on the runtime, which might be shorter or longer, typically as you would service your vehicle. Whether 15,000 kilometers comes in 2 years or in 3 years or in 50 or in 2 months, you would service it in that period. And that servicing it and managing that process could have a major reduction in maintenance cost. I think the third big thing that needs to be kept in mind when we come to smart buildings is artificial intelligence. And I think that is where I almost want to say heartbeat of this whole smart buildings operation lies, because artificial intelligence is the ability of system for artificial intelligence is the, almost want to say, functionality that gives the ability to interpret all this collected information through machine learning, through big data, and applying it to the building in various shapes and forms, to enhance the customer well-being, which is really a big thing these days. I think more so now that COVID has had a big influence in buildings. And artificial intelligence will open up a whole new way of looking and managing buildings. We tell people when it is most effective times to come to the building, to meet with colleagues, or if you've got work that you need to do, that a colleague of yours is there, or more people that you need in the meeting will be there. So it would be good to have that interaction. Artificial intelligence would be able to tell the chefs in the canteen that, listen, there's so many people in the building. This is their preferences in food, drink, whatever it may be. Artificial intelligence would be able to let staff know if there is particularly bad traffic on their way to a next meeting, and tell them that you better leave now if you want to be in time for a next meeting at a different place. So artificial intelligence, I think, is going to be playing a big role in this whole environment of smart buildings. We've already seen artificial in things like speech recognition, machine learning, planning, scenario planning, and problem solving, in seeing which aspects needs to be addressed. So what roles do the facilities professional need to be fulfilling in order to be future-proof? So what do we as facilities managers need to do? And I think one way of explaining it is, let's look at some potential future job titles. And the first one I would want to look at is transitionists. So those are people who can help in the transition from work between man and machine. Optimizers could be a next role. This is the skill to tweak variables until it produces better results. So it's that continuous improvement concept. Another one, data contextualists. So that's somebody who can provide accurate and interpret big data and give you an accurate analysis of it and analyzing it. Another one could be system anthropologist. I hope I pronounced that right. But somebody who study the aspects of the interaction with between humans and virtual systems, but also the interaction of systems between systems, and look at how that affects and direct certain aspects within the smart building and the environment. And then I think the realm of HR is also going to change, and we might have, instead of HR managers, we might have avatar relationship managers, people who manages the interaction between technology and humans. I'd love to be a fly on the wall in the first disciplinary between a machine and a human. But these are typically the type of new futuristic jobs that could exist. And I think you see that there's very much a technology-focused skill set in all of those positions. So things like programming might become a big thing for facilities manager to consider, or at least understanding programming. Analytics, how analytics work, how to apply analytics, how to interpret that analytics to make better decisions in buildings and the management of these buildings. Understanding system integration and how those systems are talking to each other, and how they might actually in some instances working against each other, depending on the overall objective. So in closure from my side, I think smart buildings give more control of the building inside the hands of occupants, and people can now closely interact with that building by adjusting temperature, meeting rooms, to meet their preferences in where they sit and what they do and how they operate. And it is definitely going to change the way facilities management functions going forward. I think that's it from my side.
Excellent. Thanks, Andre, and thanks, Martin. Thanks, James. We have had a number of questions coming through. And it's always nice to start a sort of questioning session, and we have about 13 minutes or so. Always nice to start a question session with a comment as opposed to a question. And I have to chuckle when I see these, because this is so true to life. One has got to be careful that we do not end up with information overload. And we see that in our everyday lives, don't we? Just take our smartphones. We have information overload there. So it's an old story of seeking out the technology that is required to get the job done, instead of seeking applications for technology that might be available. I think that sort of sums that up. A couple of questions around access to recordings and so on. The recording of this webinar is going to be available on the SAFMA YouTube channel, as well as on the SAFMA Facebook page. So we've got that there. When one looks at implementation in a sort of a brownfield or an existing building scenario, what would you see, or what would the panel see as the likely benefits for FM? And that ties in with another question about adding on to current systems and technology that might be in place. Who's gonna take a stab at this one?
I can give it a bash if you like. I'm busy with a 78,000 square meter building now that's about 15 years old, and we're going through a full BMS upgrade. So if you'd like me to, I'm happy to take a stab, Cliff.
Go for it.
Okay. So look, the first and most important thing that we have to do is the existing BMS on that site. It's operational, it's fine, it does its job, but it's proprietary technology. So we're in a very fortunate position where we still have another 10 odd years on our specific contract on that building. So we can think further than a developer would think. We could think further than a lot of people could think in terms of a 3-year or a 5-year turnaround. In our particular case, we're actually going through a full change of that system to an IP-based BACnet protocol system, because it's open. And the intention there is, does it need to happen today? Probably not. But in a year's time, in 2 years' time, in 5 years' time, as new technology comes out, the CEO, the minister, whoever it happens to be, may say, well, I want to put a fridge in my office that tells me when my level of Coca-Cola is low, or my level of beer is low, or my level of whatever is low. And I want to be able to plug that into the nearest switch in the building, so that the kitchen is aware the moment a drink leaves that fridge. I'm using this as one example. By the same token, I also have to change out 658 odd diffusers in that building, because the diffusers are going to move to motion and light control in that unit. So I now no longer have to go and install 3 or 4 separate systems. I have one device providing a lot of information back to the BMS. That BMS is going to be able to analyze who's in the building, what time they're there, what the temperature in those buildings are, when the light levels are on or off. And not only are we going to be able to perform the function that thing is supposed to perform, which is heating and cooling, but we're going to get a lot of other information as well, which will help us in workplace planning. It'll help us from safety and security to understand who's in the building. We don't have cameras on, so there's not going to be facial recognition in that. But it's all based around a long-term view on what's going to happen in a building, what is available today, what's going to come, and how do we create a system that's going to allow us to add to it later on easily. Is it going to be easy, Sofiso? It's not. One of the biggest tricks is that the building is occupied. We're very lucky at the moment in that the building is about 30% occupied because of regulations. So we can start changing out the low level of areas. But unlike a normal, let's say, greenfield building where you go in and you just install everything from scratch, we have to physically plan, and the installer or the installation teams are going to have to work around operating schedules. So through weekends, they'll come in and they'll change out one section at a time. Okay, so how do you retrofit all the sections? You don't do it all at once. You do it in a staged approach over several years. By the way, this also helps for your FM planning, because what you can do is you can look at which pieces of equipment are due for replacement when, and you can replace those with connected devices. An example of that, I think, Martin, you spoke about generators quite a lot. Instead of a generator with a deep sea controller, you make sure that your specification is a generator with a deep sea controller with a comms port on it, so that your building automation system can see everything that's happening in that BMS simply by connecting a cable from the nearest switch to it. And you can then act on things like fuel levels, exhaust temperatures, operating hours, synchronization, all without having to leave your building automation single pane of glass. Okay. I can talk about this for hours, so I'm going to stop there, but I'm happy to answer this in a lot more detail if it's required too.
Thanks, James. Martin, would you like to add anything to that? Because the majority of the questions that have come through are around this, and obviously coming from the facilities management sector, this would be the sort of hot topic around this retrofitting and bolting things onto what we have in terms of our infrastructures and so on.
Yeah, I'll give it a bash. There was one or two questions I've answered, just two of them already. But James is spot on. I think, like in most things in life, you can do these things the easy way, or the hard way, or the very hard way. A brownfield building is not really. It's just an easy thing to do. When you start off with a brand new building, obviously you can consider all of these things and future-proof your backbone, and then just plug everything in. I mean, this is not new stuff, guys. I mean, it's just, there's a lot of buzzword around these things. I'm seeing a question here: is this independent technology can it be linked to a BMS? A BMS was just an older version of a smart building, but to a degree, it monitored a lot of stuff and could not give you some control and feedback, and allowed you to do analytics with the data that you've had. So it was a bit more of a dumbed down version on older protocol. So the modern thing is like you getting in the car and your phone is connected to Bluetooth. So the unified network is Bluetooth or Wi-Fi. Are unified kind of protocols that allows a lot of stuff to interoperate. So if you do your homework up front and you design the network, like James said, properly on the backbone, get this through the building, get your switches in, get your stuff out to the cloud, and start slowly but surely just replacing stuff out. If the aircon system change or your old BMS is outdated, you can modernize it either with just IoT devices that plugs into the network, or you can take it through to a subsystem and then into the main system. So there's many ways to skin the cat. At the end of the day, it's dictated to by economics, not so much by the technical capabilities or the lack of technology in the marketplaces. So you can do these things. You can take old buildings, you can make them smart, obviously up to a degree, with older buildings, because you might be constrained by the physical design of the building in terms of a facade or something like that inhibits you. But the scale of the problem is just money. There's not a lot of problems. Money can solve it, but it might not just be economically viable to do so. So you've got to be smart about it. And I think as FM guys, how the margins are run on buildings and so forth. So you've got to do it where it matters.
That's key. That's key, I think.
Yeah, I think the danger is that you be carried away by all these smart things. And I think the first opening comment, I can't remember, it was by Michelle Rivarola, and that's a very valid point. At the end of the day, you're going to generate a lot of information, and it's going to mean different things to different people. But if you do smart buildings and smart systems, and you eventually get your information set on top of it, because data by itself is meaningless. You've got to turn it into information, and you've got to package that information so that the facility manager and what he or she observes from there is relevant to them, and what the occupant gets is what's relevant to them, and what the building owner gets is relevant to them. And you don't want to just flood people with just information. You want to give the right person the right information at the right time, to allow them to act upon something as well, so that these things become a lot more proactive. And I think the big benefit in reducing operating costs in buildings, if you've made the investment around smart buildings, you can, if you're smart about it and you've got the right skill sets in place in your organization, you can reduce a lot of operating costs. You don't have to send a plumber out to go and do diagnostics on a problem, or an electrician that comes out and takes 2 days to do diagnostics and come back to you. You can send them to a lighting solution and say, listen, diagnostically, that controller located there has got a problem, just replace it. So bring the spare with you, replace it. It's a 10-minute job. Instead of eventually a 2-hour problem that's cost a lot of money, and I think that's where you can see clear benefits over and above the fact that you can control your energy in buildings. But as I said, the big benefits around productivity leakage or employee well-being or healthy employees, making people work longer in the building because they like to do so and they enjoy being in that environment. That's where the big money sits, and that's not so prevalent yet in our country at this point in time.
Great, thanks for that, Martin. We've got to start wrapping up, unfortunately, and if there are, I see 1 or 2 comments or questions there, we'll pass on to the panel, and we'll get answers for you. Or otherwise, pop an email through to Sega at SAFMA, SEGA at safma.co.za, and she'll pass on any questions that you have around the issue of smart buildings to the panel. In wrapping up, I'd just like to thank Andre, Martin, and James for their time, for sharing their expertise, for sharing their experiences with us. And I think, as Martin rightly said, it's not a case. Well, James said so as well, and Andre intimated that as well. It's not just a case of, well, we have this technology available. Let's go and find a use for it. Let's make sure that we know what it is, that we understand what it is, and let's use that technology in the right applications. So thanks again, James, Martin, Andre, for sharing your expertise with us, and we look forward to the next webinar, which will be probably, well, it's going to be towards the end of September because of the SAFMA virtual conference that's coming up on the 1st of September. Thanks again, guys, and thank you for the participants for joining us, for the attendees for coming in and joining us on this webinar. And I sincerely hope that you got something beneficial out of it. Thanks very much. Cheers.
Thank you, Cliff, for hosting as well. All the best.
Thanks, James. Thanks, Martin. Thanks, Andre. Very enjoyable. Very information sharing. Very good information sharing. Thanks very much, guys.
Pleasure, guys.
Just guys, keep well.
Look after yourselves. We'll be in touch, all of us, I'm sure. I'd like to talk